Hello everyone and welcome once again to Captain Goodspeed Maths. In today's video we are discussing recurrent relationships, which are another new aspect of the OCR FSMQ course on the new Spec. So yeah, the learn objective today is to understand recurrence relationships and use them to work out sequences. So let's get into it. So sequences and recurrence relationships then. A sequence is a set of objects or numbers that occur in a certain order. A finite sequence can be defined by simply listing all its elements. It's not quite so simple for infinite sequences, however, and we use something known as a recurrence relation. So a finite sequence, basically you can just count. It basically means you can count everything. So a countable sequence is the sequence 1, 3, 5, 7, 9. An infinite sequence is not countable. So, if it goes on forever and ever and ever, if it goes ... minus 5, minus 3, minus 1, 1, 2, 3, 5, 7, ... That is an infinite sequence, and we can't count that, and it depends term by term. So we usually call the first term u1 and its nth term un. A position to term definition is a formula such as un equals 2 to the n minus 3n. This allows us to work out the nth term. So if I want to work out what the fourth term of that sequence is, I would do 2 to the 4 minus 3 times 4. So 2 to the 4 is 16 minus 3 times 4, which is 12. So the fourth term is apparently 4 in that question. A term-to-term definition is a formula such as un plus 1 equals un minus 3. So it relies on the previous term to work out the next term. This allows us to work out the next term, providing we know the current term. So example 1 then. It might all be a little bit confusing, but you'll get the idea with these examples that are coming up. So a sequence is defined by un plus 1 equals 2un plus 3 with u1 equal to 1. Find the value of u3. So first of all, we know what u1 is, and if we think about it, so what do we need? So to get u3, we're going to have to set n equal to 2, so that means we need to know u2. So you're sort of working backwards on these. So we need to know u2, so that means n equals 1. So that means we need u1. Bing, 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 bing. We've got u1 equals 1. So let's go into it. First, let's find the value of u2. To do this, we have to set n equal to 1 in the above formula, like I said before. So we get un plus 1 equals 2un plus 3. So u1 plus 1, which will turn out to be u2, equals 2 times u1 plus 3. So u2 equals 2 times 1 plus 3, which is 5. So u2 is 5. Now we need to work out u3, so we set n equal to 2 like we said before. So it'll be u2 plus 1, which will turn out to be u3, equals 2u2 plus 3. We've just worked out what u2 is, so it's going to be u3 equals 2 times 5 plus 3, which is 13. So u3 is 13. Easy, yeah? Example 2 then. Find the first 5 terms of the sequence defined by xn plus 2. Doesn't have to be u, could be x, could be g, could be anything you like. Could be zebra. But this time it's xn plus 2, which equals xn plus 1 minus 4xn, with x1 equal to 3 and x2 equal to minus 2. So first, let's find the value of x3. To do this, we set the n equal to 1, because we've already got x1, x2. So next simple step is to work out x3. So to do this, we have to set n equal to 1 in the above equation. So we get xn plus 2 equals xn plus 1 minus 4xn. So x1 plus 2, which will be x3, equals x1 plus 1, which will be x2, minus 4x1. So x3 is minus 2 minus 4 times 3, which equals 14. Because remember, x2 is minus 2 and x1 is 3. So x3 is minus 14. And then we do the same for n equals 2 and 3. So we get x4 equals minus 14 minus 4 times minus 2, which equals minus 6, and x5 is minus 6 minus 4 times minus 14, which equals 50. So the first 5 terms are 3, minus 2, minus 14, minus 6 and 50. So completely random there really. So yeah, here's an exam style question then. David invests an amount of money on June the 1st, 2021. No idea why that's the date, it just is. Compound interest will be paid annually at the rate of 3%. The initial investment is denoted by £A1. Its value after year 1, which is June the 1st, 2022, is denoted by A2, and so on. So, part 1. The value of an plus 1 is given by the recurrence relation, an plus 1 equals kn, where k is a constant. Write down the value of k. So, the compound interest is 3%, which is 0.03, so our value of k is simply 1.03. So that is something that should just drop onto the page. Remembering from compound interest from GCSE, you should sort of know that 3% interest means that you get 1.03 times your money every year. So value of k is 1.03. Part 2 then. David's initial investment is £5,000. Find the value of his investment on June the 1st, 2025. So I've got there, recall that an plus 1 equals 1.03 an, and we also have a1 equals 5,000 because that's his initial investment. So a2 is 1.03 times a1, because we're letting n equal 1, remember, to get a2, because it's n plus 1, so n is 1, which turns that into a2, and turns that into a1. We know what a1 is, 5,000, so it's 1.03 times 5,000, which is 5150.00, because it's money, remember. So a3, similarly, we let n equal 2, so that becomes a2. a2 we've just worked out, so we sub that in there, and we get that. And similarly for a4, we get 1.03 a3, because n is 3 this time. We've just worked out what a3 is, we sub that in there, and we get 5463.64. a5, similarly again, we let n equal 4, so it's 1.03 times a4, which is 1.03 times 5463.64. So that is our final answer. On June the 1st, 2025, which is his 5th year of investment, he will have this much money in the bank, which is pretty good actually. 627 quid for just sticking it in a bank for 5 years. Part 3, find an expression an for its value after n years. So let's have a think about what we've been doing here. So every year we've been times them by 1.03. So we're simply multiplying what we had before by 1.03. But this 1.03 is the only constant in there. So we've multiplied by n minus 1 times. So if you look at it here, so a2, so n is 2, 1 is n minus 1. So for an equals to 1.03 an minus 1, we've multiplied by 1.03 n minus 1 times. So that means an equals 1.03 to the n minus 1 times 5,000, because we've done it n minus 1 times, and we've kept times in our initial investment. Even though it may not seem that way, that is what we've done. So our expression is a little n equals 1.03 to the n minus 1 is 5,000 times 5,000, and that is it. That is recurrence relationships. So if you found that helpful, then make sure you leave a like down below. I do want to say thank you for watching it all, and let me know how to make these more helpful down in the comment section below. One of the feedbacks that I got was putting exam style questions in, so that's exactly what we've done the last few lessons, so hopefully you found that helpful. All of the lessons are uploaded to the Google Drive, and of course there's the FSMQ playlist. I do just want to draw your attention quickly to the fact we've only got 5 lessons left after this, so I've recorded all these ones today. You're seeing this one, So we only have, 6 lessons. Maths teaching, and I don't even know how to count. But we've got 5 lessons left, so those are the things to come. This is something new, as is this. So we've got change of sign and interval bisection, we've got convergence, we've got trapezium rule. So those 3 are all sort of new things on the spec, as is permutations, but things like binomial expansion and combinations and binomials are in the old playlist as well, binomial probability that is. So there's actually only 4 lessons of new content to learn, and hopefully you'll come along for that, and you'll find it helpful. So subscribe for more FSMQ videos, and thank you very much for watching. Best of luck for your FSMQ.